Hello medicos, today we are going to see platelet aggregation. See, these are endothelial cells. And this is subendothelial collagen. Due to the injury to the endothelial cells, there is exposure of subendothelial collagen and von Willebrand factor. There is a circulating platelet. It has GP1B receptor which will bind to this von Willebrand factor. So this platelet has vesicles. There will be exocytosis of these vesicles. It will release its content. What are its content? 5-HT, ADP and thromboxane A2. Now consider this another one platelet. Okay. Now this thromboxane A2 has a receptor called TP receptor on platelets. T for thromboxane, P for prostanoid. Okay. Now this is GQ coupled receptor. This thromboxane will act on this TP receptor, GQ coupled receptor. There is activation of phospholipase C. So now it will convert PIP2 into IP3 and DAG. This IP3 will act on endoplasmic reticulum. Okay. Now there is a release of calcium. There are vesicles inside this platelet also. This calcium will cause exocytosis of these vesicles. There is release of again 5-HT, ADP and thromboxane A2. So IP3 caused release of 5-HT, ADP and thromboxane A2, which will further lead to platelet aggregation. Now this DAG will produce protein kinase C. See, there is a receptor called GP2B3 receptor on both the platelets. They are holding this fibrinogen. Okay. Due to this fibrinogen, there is aggregation between the two platelets. This protein kinase C will regulate this GP2B3A. So it will cause more binding between the platelets. This is how thromboxane A2 will act. There is a receptor called 5-HT2A receptors on platelets on which 5-HT acts. This is also G protein coupled receptor, which is GQ. In the similar way as thromboxane, it will also cause platelet aggregation. Okay, then what is the role of ADP? This ADP will act on, for ADP acting, there is two receptors. There is P2Y family, which has P2Y1 and P2Y12 receptors. This P2Y1 receptor is also G protein coupled receptor. It is GQ and P2Y12 is GI. Okay. Now these two receptors are expressed on platelets. Okay. Now this ADP will act on both the receptors. Okay. By acting on P2Y1 receptor, it is GQ. In the similar way as thromboxane and 5-HT, it will also cause platelet aggregation. Now what is the role of this P2Y12 receptor? It is GI. Okay. What it will do? It will inhibit adenyl cyclase. Adenyl cyclase, what it does? It converts ATP into cyclic AMP, then into protein kinase A. What is this protein kinase A will do? It will convert VASP into VASP phosphorylated form. What is this VASP? VASP is nothing but vasodilator stimulated phosphoprotein. Okay, vasodilator stimulated phosphoprotein. This VASP will activate this GP2B3A receptor. So it will also cause aggregation. So now see, P2Y12 receptor on which ADP acts, there is activation, there is inhibition of adenyl cyclase, which will cause less cyclic AMP formation, less protein kinase A formation. So VASP will be more. This VASP is active form. VASP in phosphorylated form is inactive. So there will be more VASP in activated form. So this will lead to the more activation of GP2B3A receptor. So there will be more platelet aggregation. Okay, this is how ADP, thromboxane A2 and 5-HT will cause platelet aggregation. We will come to adenosine also. Okay, see, we saw about P2Y receptors. See, there are P2X receptors also. They are for ATP, and this P here represents purinergic. ADP, adenosine, purinergic. Okay. Here, as we said, what here T represents thromboxane, P represents prostanoid. Okay. Now, what is the role of adenosine nitrates on platelet aggregation? What they will do? What these nitrates and adenosine will do on platelets? And another one thing we can see is prostacyclin, PGI2. What these three will do on platelets? See, adenosine has receptors A1, A2, A3. Sorry. A2, A3. A1 and A3 are GI. A2 is GS. Okay. A2 also has two forms, A2A and A2B. There is expression of A2A and A2B receptors on platelets on which adenosine acts. Both are GS. So what will they do? They will activate adenyl cyclase. There will be more cyclic AMP, more protein kinase A. VASP will be phosphorylated. So there will be inhibition of platelet aggregation. So adenosine will cause inhibition of platelet aggregation. Now let's see nitrates. Nitrates. See, there is an enzyme called mitochondrial aldehyde dehydrogenase. This is present in platelets, but it is present in minor quantity. But still, it can cause somewhat platelet inhibition. How? Nitrates is converted into nitric oxide. This nitric oxide will act on soluble guanyl cyclase. Soluble guanyl cyclase activated. Now it will convert GTP into cyclic GMP. Now it will form protein kinase G. In the similar way, how protein kinase A phosphorylated VASP, in the same way protein kinase G will also phosphorylate this VASP. So when VASP is phosphorylated, there will be inhibition of platelet aggregation. So this is how adenosine also caused platelet aggregation, inhibited platelet aggregation, and nitrates is also inhibiting platelet aggregation. Now let's see prostaglandin I2, prostacyclin. There is a receptor called IP receptor. Similar way of TP, there is IP. Here also same. I, prostaglandin I2, I, and prostanoid receptor, so P, IP. Prostaglandin I2 will act on this IP receptor, which is G protein coupled receptor. It is also GS. So in the similar way as adenosine, it will also cause activation of adenyl cyclase. There will be more cyclic AMP formation, more protein kinase A formation, and it will phosphorylate VASP. So there is platelet aggregation is inhibited. So all these three, adenosine, nitrates, and prostaglandin I2, prostacyclin, they will cause platelet aggregation. Is inhibited. Okay, these three will cause platelet aggregation will be inhibited by these three. See, this cyclic AMP can be converted into 5-AMP by phosphodiesterase 3. So the drugs which act on phosphodiesterase 3 can cause more cyclic AMP, which will inhibit phosphodiesterase 3, will cause more cyclic AMP, and it will cause platelet aggregation will be inhibited. And there are drugs which act on P2Y12 receptors. There are drugs which act on GP2B3A receptors also. So this is how platelet aggregation is caused by thromboxane, ADP and 5-HT, and inhibition by adenosine nitrates and prostacyclin. Thank you.